This is an experiment to determine the mass of a tennis ball using circular motion. The tennis ball I've actually punctured twice, threaded a string through and made sure that's very firmly attached. The string passes through the barrel of a pen, and on the other end of the string is a 400 gram mass. If I set the ball into circular motion, you can see that the tension in the string is actually supporting the 400 gram mass. As I make the ball move faster, the tension in the string increases and the ball can actually lift the 400 gram mass. I've set the ball into motion and now I'm going to see how many revolutions are completed in a 10-second period. 10 seconds starts now. And ends now. The ball completed 16 revolutions in the 10-second period. I've caught the string and trapped it with my finger so that I can measure the length of the string. Measuring to the centre of the ball gives me 57 centimetres. I'm making some quite big assumptions here. I'm going to assume that the ball follows a circular horizontal path and that the weight is insignificant. So if that's the case, then the tension in the string will be the resultant force, and that will be equal to the mass times the acceleration, which will be r omega squared. Looking at the heavier mass, we can see that T, because this mass remains at rest, must be equal to 0.4 g. That's the 400 grams that we use for the mass. So 0.4 g will be equal to m r omega squared. To find the value of omega, we need to consider how many radians will be swept out in 1 second. The ball completes 16 revolutions in 10 seconds, so that's 1.6 seconds per revolution. Each revolution will be 2 pi radians, so that gives us a value for omega of 10.1 radians per second. We will take the radius as being the length of the string, so r will be equal to 0.57. We can now return to the earlier equation. M r omega squared equals 0.4 times 9.8. Substituting into this, we have the m, which we're trying to find, the radius 0.57 times 10.1 squared equals 0.4 times 9.8. If we solve this for m, we will get m equals 0.067 kilograms, or 67 grams. I will now put the ball on the scales and see what we get. So according to the scales, we have 59 grams as the mass of the ball. That compares quite well to our 67 grams that we predicted. This is quite a tricky experiment to get right, and you might need to have several attempts. I certainly did, to get a reasonable answer. Part of the trick is trying to find a speed at which you can spin the ball, but it's kind of in the middle of the big mass wanting to move up and down. A bit of experimentation is definitely necessary for this one.